Okay, let's give you guys some more practice. So here, find the limit of this here as x tends to 0. And just as a hint, try to aim for one of try when possible. Try to aim for these here. If you can get sine x over x, then you know as x tends to 0, then the limit will be 1. Or you could try and aim for this, where you know the limit is 0 as x tends to 0. And remember, if you have any function that heads, well, if the limit of any function as x tends to 0 equals 0, so basically if you have any function that goes through the origin, like this one here, well, it could be any function. If any function here, if the limit is 0 as x tends to 0, then the negative version of this function here, then the negative version of this function will always go through the origin as well. So my point is that no matter what function you have, if this function here goes through, heads towards the origin, then the negative version of this function, which is this function here, will also have a limit of 0. So my point here is that, well, I've done a video on this, so if you don't understand it, maybe you have to track that video down and watch it. But this limit here, as x tends to 0 of this function here equals 0, then the negative version of this function here, which is this one here, because you times -1. Now the negative, so because we know that the limit of this here goes through the origin, then the negative version of this, which is this one here, the limit it will also be 0. Just bear that in mind. Okay, so try to aim for this. Maybe aim, well, when you're doing limits, try to aim for these three. It will simplify a lot of things. Okay, so here let's okay, so well, do whatever you have to do. Find the limit of this as x tends to 0. So press pause and have a go. Okay, when I first did this, I took the wrong road because my eyes zoomed into this bit here, and then the minute I saw this sine squared, I immediately thought about this. I immediately thought about 1 equals cos squared x plus sine squared x. I immediately thought, I don't know why, but this here is the wrong way of doing it. You see, I replaced sine squared x as, well, here take away cos of x, cos squared of x from both sides. So it will be 1 minus cos squared of x equals sine squared of x. And then well, my eyes zoomed into this sine squared of x. So I'll replace that with sine squared of, well, I'll put that into here, giving me this here. Okay, but then it would take, then I got to this stage where I broke up the fraction like this, and then it took me to this stage here. But then I got stuck on this bit here. So I had to go back to the beginning. My point is that when given a limits problem, try to play around. You won't get it right the first time, so you have to play around with it. Sometimes you get it wrong, so you start again. In my case here, I took the wrong route. I replaced this with 1 minus cos squared of x, which was not a good move because well, I got stuck when I got to this stage here. So I had to go back and had another go and have another go. So here, if when you're here, visualize now. This was the original question. Our aim is to solve this. Up here earlier, it was a wrong way of doing it. Up here, it was I went down the wrong road. So well, anyway, here, so visualize this as a 2 times a sine of x times a sine of x, and then down here visualize this as x times times cosine of x time. But basically you've got a block here multiplying with a block here multiplying with a block here. At the bottom you've got a block here multiplying with this block multiplying with this block here. And then now well, move this block out and move this one out here. So So you have this. So this whole thing here can be written as this block multiplying with this block here. Okay, and then now well, you take the limit of this and then take the limit of this. So that will give you this here. So the limit of this here is 1, because well you at this stage you just have to know that sine x over x as x tends to 0 is 1. You have to know this by now. Okay, and then this one here, if you look at it, hang on, if you look at this here, as x tends to 0, so if you put 0 into here, nothing breaks down, because here you've got well, nothing breaks down here, because at the moment you've got a 2 multiplying with a sine of x. So when you put 0 into this x here, sine of x is 0. So it's really 2 times sine of x. This is your sine of x here, which is 0. And then at the bottom here, well, put the 0 into the cos of x. That would be a 1 times a 1. You see, you've got a situation where a situation where nothing breaks down. You see, this is legitimate. This is really 0 over 1, which is allowed. It's only a problem if you have 1 over 0. This here is a problem. Whereas R1 here, 0 over 1, is allowed. It's okay. Nothing breaks down. Nothing breaks down here. So this thing here is actually 0. So you've got 1 times 0, which is 0. Okay, so when you look at the graph, it will look like this. Dead on 0 here is undefined, but the limit as x tends to 0 is actually 0. Okay.